The lighting system is the most helpful to the pilot in the dark of night or in poor visibility due to fog, snow, or rain. Today, let's look at the runway lighting system. Runway edge lights are used to outline the edges of runways. These lights shall be placed along the full length of the runway in 2 parallel rows equidistant from the centerline. The runway edge lights have a white glow. In the caution zone, which is the last 2,000 feet of the runway, yellow lights replace the white lights. The yellow lights indicate caution on rollout after landing. Threshold lights emit green light outward from the runway and red light toward the runway to mark the ends of the runway. Green lights indicate the landing threshold to arriving aircraft, and the red lights indicate the end of the runway for departing aircraft. When the displaced runway area is usable for takeoff, red and yellow runway edge lights are installed to delineate the outline of this area. In this case, threshold lights are located outboard from the runway. The displaced runway is not usable for landing, so threshold lights are installed in red to alert the landing pilot to this area. Taxiway edge lighting systems are configurations of lights that define the lateral limits of the taxiway or apron. The taxiway edge lights emit blue light. The precision approach path indicator provides visual approach slope information. The system provides a white and red light projection pattern along the desired descent path to the touchdown point. Landing pilots can determine whether they are high or low relative to the ideal glide path by checking the number of white and red lights. PAPI is generally operated both day and night. Approach lighting system provides the basic means to transition from instrument flight to visual flight for landing. Pilots landing on days with very low visibility will probably notice these approach lights before the runway. This configuration is an ALSF2, commonly used for precision approach runways, and is generally 2,400 feet from the threshold. The approach lighting system includes flashing lights called sequenced flashing lights. The sequenced flashing lights emit a continuous white light from the end of the approach light to the 1,000-foot bar. The approach lighting systems are installed in a variety of lengths and shapes. Let's look at typical configurations. Runway end identifier lights can be installed in the case of non-precision approach runways or an additional need to identify the runway threshold. This system consists of a pair of synchronized flashing lights located laterally on each side of the runway threshold. This is expressed through runway threshold identification lights in ICAL, and the primary function of the rail is to supply rapid and positive identification of the end of a runway. The lead-in lighting system provides positive visual guidance along an approach path, either curving or straight, where special problems exist with hazardous terrain, obstructions, or noise abatement procedures. The lead-in lighting system consists of one or more series of flashing lights installed along the approach path and may be terminated at any approved approach lighting system. Typical runway lights are lights that have some height from the ground. However, if lights should be installed on the path through which the aircraft passes, it should be made of in-pavement light fixtures. From now on, let's look at representative in-pavement lights. The runway centerline lights are located along the runway centerline at 50-foot equally spaced longitudinal intervals. The runway centerline emits white light, but the last 3,000 feet of the runway is color-coded to warn pilots of the impending runway end. Alternating red and white lights are installed starting from 3,000 feet, and red lights are installed in the last 1,000. Touchdown zone lights are installed on some precision approach runways to indicate the touchdown zone. The system consists of steady burning white lights which start 100 feet from the threshold and extend to 3,000 feet. Taxiway centerline lights provide taxi guidance between the runway and apron areas. Taxiway centerline lights are green. Runway guard lights are yellow and should be installed at the runway holding position. They provide a visual indication to anyone approaching the runway holding position that they are about to enter an active runway. Stop bar lights provide a distinctive stop signal to anyone approaching a runway. A stop bar consists of a row of unidirectional, in-pavement red lights and an elevated red light on each side of the taxiway. The stop bar lights are generally operated at low visibility conditions. Pilots can enter the runway only with the stop bar lights off and the controller's permission. It is set to be manually operated by the control tower or automatically operated by the sensor. Lead on and off lights provide visual guidance to pilots entering or exiting the runway. Alternate green and yellow lights are installed from the taxiway center line to runway center line. In airports with rapid exit taxiways, rapid exit taxiway indicator lights are installed to make it easier for pilots to identify the location of these taxiways in low visibility conditions. Rapid exit taxiway indicator lights shall be installed with unidirectional yellow lights. In the last video, we learned that runway markings change depending on the runway type. The required lighting system is also different depending on the runway type. Every runway lighting system is operated not only at night, but also when the weather is bad. The controller at the control tower generally adjusts the intensity of the lighting based on the regulations and turns on or puts out lights. We have now learned about the lighting systems at the airport. We will end here today. Please like and subscribe if you think it was useful. It'll support us a lot.